Hey everyone, welcome to Elite AI Assisted Coding. Today we have Samuel Colvin from Pydantic. Samuel is the founder of the Pydantic Library and of the Pydantic Company. I think Samuel, you have a reputation for taking stuff that's headache-inducing and making it accessible and manageable to people, first with the runtime validation and now also with Pydantic AI and indeed with Pydantic Logfire. I already saw them. Pydantic Logfire happy user. It's the first thing I drop into every new project because it just makes observability so easy. But I don't have yet any experience using it with an MCP server, so I'm eager to learn. So over to you, Samuel.
Yeah, thanks so much. Thanks for having me. Yeah, I can do a few different things in this talk. I can start with a like very simple intro to Pydantic AI and Logfire, and then go on to show a bit some more complex use cases. I wonder if I could just do a quick show of hands of how many people, or maybe you know this already, I don't know, how many people here have tried Pydantic AI, so I know whether to assume knowledge. Can I do a thumbs up if you have from the reactions?
Yeah, people, you can. Okay, we have Dimitri knows it.
Okay, so not by any means everyone. Okay, that's fine. So I'll start with a super brief example of Pydantic AI, show that running simply, and then running slightly more complex cases, and then use Logfire to instrument it, and then we might go on to the kind of party piece of using MCP to fix bugs automatically. So I share my screen, and I'll come over here. I don't want that file at all. I want Pydantic AI simple. I'm going to get you guys out the way so that you can see this, and hopefully this code is visible to everyone. I can if it's not, please comment, and Eleanor, please let me know, and I will try to make things bigger. This is a kind of borderline hello world example of Pydantic AI. So we're importing the agent. We're defining our agent here. We have the return type set to be, in this case, person, which is a Pydantic model. We take type safety very seriously within Pydantic AI. So if you look at agent, it is generic in the output type, which means that when we access result or output, it is an instance of person. And so if I tried to access output.name, it would autocomplete for me. If I tried to access first name, I would get a typing error saying first name is not an attribute of person, etc., etc. Only other main thing to say here is we're instrumenting it with Logfire, which is just these 3 lines of code. So we're importing Logfire, instrumenting it. We set a service name just so if we run a number of different examples, you'll be able to see which one's which, and calling instrument Pydantic AI, which is going to basically generate OpenTelemetry spans for our call. In particular, it will emit those OTel spans will be semantic convention compliant, so they'll work well in Logfire, but in theory, you can send data to any OTel platform. And then finally, in this case, we just print the out or log the output with Logfire. So if I go ahead and run this very simple example, it should be pretty quick to finish. It has been, and you'll see we get a very basic trace of what's happened in the terminal. But also, if I come over to Logfire, maybe the connection has died. But if I look at this last case here, this was the call to our agent. We can see the exchange with the LLMs. So we had the system prompt, the user's input, the output, which in this case we used tool calling to do the structured output. We can look at the details of the, in this case, only call to the model itself, and then we can see the output type. One thing to call out here in Logfire is we work hard to show things as if it was repra. So although this is really structured data that we could go and query on, we display it like it's just a repra in your terminal, making it nice to see. Obviously, person isn't that complicated, but when we get to more complex objects, it'll be useful to be able to see that. I'll go on to, obviously, please interrupt me if anyone has any questions or anything is unclear. If you have questions, you're probably not the only one. But I'll move on to a slightly more complex examples. This is basically the same code, The only difference is we're being slightly mean to the LLM. So we have a Pydantic validator asserting that the person who we're extracting from the structured data needs to have been born in the 19th century, not in the 20th century. And obviously the LLM would assume that January 28th, 87 would be 1987. So when we run this, we will demonstrate reflection within Pydantic AI. So it will use the validation error when it tried to validate the structured output against person to prompt the model to retry and thereby get hopefully the correct data the second time around. So if I go and run this example, and we look at the output still coming in here, you'll see we have two, in this case, we have two calls to the LLM. You can see their relative duration, also the token counts, and of course, we also have the cost on how much that run cost you. But you'll see if you now look at the exchange, we had two different calls. So the first time, as you would imagine, the model returned 1987. We then returned the validation error to the model, saying, and said, please try again. And it now successfully worked out from the validation error what to do and indeed returned the right year. And this, I obviously have a slightly contrived example in this case to get it to fail with a kind of understandable use case. But you'd be surprised how often the model misinterprets the schema, even though it has the JSON schema, gets it wrong. And one basically prompt to retry is enough to fix the model. I'll go on to show another example that actually doesn't use Pydantic AI, and then I'll break that and show how we can use MCP to fix that. So if I go in and I'm gonna run a fast API example here, and I can show you the code. I mean, at its heart, it's image generation based on a prompt. So here we're not using Pydantic AI, we're using OpenAI's SDK directly. And we're generating an image, and you'll see that here we're instrumenting OpenAI with Logfire, so we should still get that call. So if I run this example here and run the UI that it gives us, then it asks us to prompt to generate an image, and if we say cat wearing a hat, for example, hopefully the LLM will go off and generate us a nice image of that. If it wants to finish. In fact, we can come over here and we can even see the trace coming in as that DALL-E 2 generation is ongoing, and we've now seen it completed. And so we get this nice picture of a cat, and we can, but even more valuable in Logfire, we can see the exact exchange with the LLM. Obviously the prompt here was extremely simple. And we can even see the output of exactly what it returned. And we can see that then, obviously, what actually gets returned, if you look at the actual data, is this URL pointing to the blob, which contains the image. And so what the app then does is goes and gets that image and re-renders it, and it prompts the front end to make a new request to get the image, which is then what is displayed. So one of the differentiators with Logfire versus other AI observability platforms is that we're full observability. So you get, in this case, stuff about the fast API arguments, the headers and responses, as well as obviously the LLM call. I can't see anyone. Is this making some sense? Where I'm kind of talking into a vacuum, and then I can go on to a kind of more complex example if that's making sense.
And I think it's great so far, and you can probably introduce more complexity. And everyone remember that you can drop something in the chat or just unmute yourself if anything comes up.
Yeah. So unusually for a demo, everything so far I've shown you has worked. But let's look at what happens when something goes wrong. And in this case, I will have a slightly contrived mistake where I'm going to change this method here. I thought it was called create, not generate. So now I have a bug in my code. Now, obviously here type hinting is giving me an error, and I've also got Git is telling me that this line has changed. Now I very specifically am going to run this example from inside the subdirectory, and then I will run Claude to fix this from within the subdirectory, and that's primarily so that Claude doesn't have access to Git's version history to work out what's wrong. Because if you run this case where you've just made this error and it has access to Git, then Claude will go and fix the error by basically reverting the commit. But if I go and run this example again, you'll see what I mean by that in a moment. So if I go and run this, come back to the UI, and I say whatever, and I run the example, I get back an error. Okay, now obviously I made a relatively obvious mistake here, but like, which you can, and obviously Logfire now shows me the traceback async image object has no attribute create. Now we know what we did wrong here, but let's assume we didn't, and we want to go and fix this quickly. We have this fix with AI functionality here. Now this gives us the command we want to go and run, but what I'll do first, I'll come over here. I'll post the commands, but instead of piping it straight into Claude, I will just display it in the terminal so you can see, or should be able to see what's printed out. So this prompt to Claude is what we're going to use as an entry point into trying to fix this bug. So the prompt to Claude is you must call MCP Logfire arbitrary query and then run this query against the database. Something else I didn't talk about in Logfire, but I can go into in more detail, is that we allow you to run arbitrary SQL against your data. Now that's useful for individuals. It means you don't have to learn a new DSL to use Logfire, but it's also very powerful for LLMs because LLMs are great at writing SQL. So we kick it off by giving it the SQL it wants to run to go and find this particular trace. But the power here is that where Claude or your equivalent coding tool is needs to like investigate further into Logfire, it can go and write its own SQL to query your data. So it effectively gives equivalent of a UI for the AI to go and investigate. So if we go and pipe this into Claude, and the gods of demo are with us. And so, sorry, I should also explain that the way this is going to work is that Claude has access to the Logfire MCP server, which has a bunch of tools, including the capacity to run SQL. So in this case, we're using an arbitrary query tool, or encouraging Claude to use the arbitrary query tool to start the investigation. So if I kick this off,
sorry to jump in, but I just wonder, do you think it's worth running the same query from the UI just to see, for people who haven't used Logfire, to show how it looks like? First, because it's not as possible to see what Claude will be seeing.
Yeah, I will. And actually, I'll let this run now. I've started it, and then I'll show you what it was doing. So Claude will go off and investigate, but obviously, in particular, it ran this query, and so it's almost immediately found the error based on the exception that it got back when it ran this query. And so if you asked it to fix it, it will now go and update that. But you're quite right, Eleanor. I will, once that has it now wants to go off and test it, which I'm kind of done with. So we'll stop. Eventually I'll be able to kill Claude, and indeed it's gone and fixed it. But yeah, you're right. Let me go in and show you. So one of the powerful bits of Logfire is you can run arbitrary SQL against your data. So obviously I only have one span on screen, but if I go back over the last 6 hours, I've been doing a whole bunch of stuff. I have lots of data here. If I come in here to search, I can effectively write the where clause of SQL to go and investigate my data. And we have a bunch of affordances to make this easier for you. But if I go and run this particular trace ID query, we immediately get to the particular span where the error happened. But you can also run more complex queries. You could search for example, service name was fast API example, and that will show us all of the spans from this particular example. Or we could look for spans that were longer than 10 seconds if we wanted to start looking at slow requests, and then we could see details of any of our spans where traces where there were spans longer than 10 seconds and investigate what had happened. I think the other thing, just to get to Eleanor's point, if I take the full SQL that we asked it to run, we also have this explore view, which you don't need to use that often in Logfire, but it's powerful. It's a kind of equivalent of a Jupyter notebook, but for our data. And so you can go and run arbitrary SQL against your data, and you can see then the actual data that the LLM would have had access to go and try and fix the bug. So if you look at the trace back here, you can see it had access to the traceback, and that's how it was able to relatively quickly work out what the error was. This is a slightly contrived and simple example, but you get the idea. That all worked relatively quickly, so I think it would be useful. Well, Eleanor, I don't know if you have anything particular that you would like me to show in Logfire, or otherwise I can show you some of the more complex MCP instrumentation, which I think is quite powerful.
I'd love to see more of the MCP workflow you have. Oh, and there's a request here. Could you paste in this space the website of the GitHub repo that you're using so people can follow? If it...
Yes, I can. It is here. It is Pydantic Stack demo, and you will see all of the different examples there. And if I have to come out of sharing for 1 minute to paste the link there, and that has a number of different examples in it. But in particular, the ones I've been showing. I'll share my screen again. The other thing I could show you is our evals, which we've just very recently released our evals functionality. Would that be interesting, or some more MCP stuff? Which would you prefer?
Yeah, I'd love to see a bit more of kind of your MCP workflow, because it's just one of these things that you learn from watching someone doing it at their terminal better than any other way. But yeah, if we have time, also super curious about evals.
Okay. Let me see what the best way of doing that would be. I don't have another setup case for using our MCP server, but I will see. The other thing I'll do, I think partly out of curiosity, is to see whether or not it will work with Zed's MCP server. Zed's editor instead of Claude Code, because obviously it's not limited to Claude Code. So in theory, if I come in here, let me see if I've got. So I have Logfire's MCP server connected, and if I turn it on and the gods are with me, this may not work. If I find Zed's support for MCP is not as sophisticated as it should be, but I was hoping that I would be able to show it with Zed as well, but context servers, where's Logfire? That one is wrong. I'm just going to try and see if I can fix the Zed config and see if that's going to help it run. But if it doesn't work, then I'll go back into Claude and just use Claude. It might not have access to the right to the access token. So I think that's not going to work right now. So I won't use Zed. In theory, it's possible to configure it. Our repo for Logfire MCP contains details on how to do it. The main thing you need is that you need access to this Logfire read token to be able to obviously query data within Logfire, and that is what Zed doesn't have configured right now. But I'm not going to mess around trying to show you that right now. Instead, I will just get on with showing you another. Well, I can show you another. Well, I think.
So just a quick question regarding the MCP. So do you typically run it locally, or do you have an endpoint to do the kind of HTTP MCP connection?
The moment our MCP server is running over standard IO, so it's a local MCP server, I think in time we will move it to being hosted and running over streamable HTTP. I don't think we haven't done that work yet. And I mean, the user experience for you will be very, very similar. I guess it will just get updated a bit more easily than having to run at latest. But at the moment, it runs over standard IO. So yeah, one of the other nice things that I think I can do, which I'll try and I'll see how it works. But I didn't demo this before, so you'll get the fun of this working or not working. If I say use Logfire to find this slowest HTTP endpoints in the last hour and tell me why they're slow. So now we're doing a much less specifically fix this thing and like more investigative kind of query. And hopefully generally Claude is quite good at working out how to use these tools. So yeah, so it's going to go and get the Logfire reference, which is basically it's asking for a couple of different tools. That's basically giving it a whole bunch of context that it will use to formulate its SQL. And you see it's now running a bunch of arbitrary SQL. It got a validation error, but it's got an error in the SQL, which it then fixed. So it's now going and looking at, it's immediately found that generate endpoint that we were calling just now being slow. So it will then, I guess, investigate why that one was slow. And I think this is this is almost as useful as the fix and exception case, where it's more like open-ended, investigate why stuff is slow. And obviously, this particular demo project I've been running doesn't have anything very interesting in it. If you were running and it's immediately come back and done a pretty good summary of, so the generate endpoint is taking 5 seconds on average. The static image is taking 0.3 seconds, probably not worth worrying about, and the basically a breakdown of the other endpoints. So it does a pretty good job for cases like this. And you see it's even pulled out this issue that it had earlier about the create endpoint. So it's great for situations like this. And in fact, it's seen that 60% of cases failed, which is obviously me just trying it quickly before this trial. That makes sense? Any questions on that?
Yeah, this is so cool. One thing I'm wondering, when you hook up the MCP server to an agent like Claude, do you find that he needs to instruct it carefully how to use it, or does it mostly figure it out by itself just from knowing about the tools?
It's pretty good at just understanding it. There is a subtlety, which is that lots of basically resources in MCP. I don't want to go into a whole diatribe on the internals of MCP. I was at MCP Summit last week trying to work through some of this stuff, but it's not at all clear when and if you should include resources. And so we have a resource, which arguably MCP servers should automatically go and get, which basically contains lots of detail on how to do it. It is a system prompt basically for using Logfire, right? As an MCP server. And I'm pretty sure that Claude by default will automatically inject resources into the context. But we also have that content available as a tool, which I think it went and ran as well, because I suspect it's injected that context twice in this case, because given that lots of MCP servers don't support resources yet, we have to have it available as a tool as well. Does that sort of answer your question? I mean, I suppose the summary is, I think I can do this. I can go Claude MCP list. And that will list me the MCP servers. And then I think I only have Logfire configured. And I think I can make a query to get me, get Logfire. And that will show you, that does not show you the list of tools. But in theory, if you could get a list of tools, you would see the particular tools that are available, and there aren't very many in this case because they don't need to be. But yeah, basically the list of tools is pretty concise in this case, particularly because we have this capacity to run arbitrary SQL, which basically covers all of the complex use cases. So it's amazingly good at working it out. I mean, you can see here in this case, it generated some SQL that was invalid. And the error was it tried to use percentile cont, because that is a method in Postgres, and our SQL is more or less Postgres flavored. The method in Data Fusion is called approximate percentile cont. It's a stupid name because it's accurate to 6 decimal places, but they decided to call it approximate. But that the response was good enough in indicating what it should do differently, that the next time it ran that query, it used approximate percentile cont, and therefore got back accurate details on the different on the different HTTP endpoints, and then was able to generate this summary. Does that make sense?
Yeah, totally. There are a couple of good questions here in the chat. One is, would you use this MCP server also from an environment like a notebook or something like this, just as an easy way to connect to Logfire?
Yeah, yeah, it works pretty well for that use case as well. I mean, you could even connect, you could go round in a circle and you could connect it to, in fact, let me try that. If we've got, I've only got a couple of minutes, but if I had time, I would show you trying to connect that to with Pydantic AI itself, and then you could basically build your own agent for investigating Logfire using Pydantic AI, and it would work pretty well. But you can use it from Python code. Yes, absolutely.
And one more general kind of MCP question. What was your experience using this with Claude in comparison to other drivers like Gemini CLI or other tools?
I haven't used Gemini CLI very much. I use Zed as my editor, and I hoped to be able to show it in Zed, and Zed is more frustrating to run it with. I will say, I've in my experience, Claude does the best job, and I think. I mean, my impression from what people say is people prefer Claude to Gemini CLI, and even Zed are moving towards Claude being the default, which is why they just yesterday added support for Claude Code inside. So in fact, maybe I could do it this way, because now I'm running Claude Code from within Zed. Maybe this would work. It's installing, so I won't go subject you to watching me try this, but in my experience, Claude Code does the best job in most cases. Go on then, I'll try it once, since in this case it was able to. Let me take my query here and see whether or not Claude running inside Zed has access to that MCP server, and therefore will give us the nicer UI of the same thing. But if this works, which I know only came out yesterday, I think this would now be my default way of running Claude in many cases. Because it should be able to give us a better summary of what the responses were without littering the whole of the response. Although if they're not going to show, oh yeah, they do show me. So if you see it's got SQL references, and then it's run a query, and I can go and look at the specific responses it got to each one. So this is basically doing the same thing with a slightly nicer UI. And I think in theory, it should be able to, yeah, it's giving me a similar summary of what endpoints are slow, as you would expect, as it's the same tool. Does that sort of answer your question? Oh, and in fact, it's even generated me a link to go straight in, and apparently it's got that link wrong, because I know what the problem is. I need to go back further, and now, yeah, it's taken me specifically to the span where the trace where the slowdown was, so I can now investigate what was going on inside this to be slow.
This is so cool. One last question for me. Do you ever use the Logfire MCP also to write back to Logfire, kind of as a way to instrument your agent, or is it read-only?
So separately, we have, I'm not sure if this is your question, but we have separately support for instrumenting MCP from within Logfire. So this particular case here is, and then we have distributed tracing. So in this case, let me run this example. If we don't have a hard stop right now, I could just run this example. Is that okay?
Sure.
So in this case, we have an MCP client and an MCP server. Again, they'll connect over standard IO just to make running them nice and easy, but this would work just as well over HTTP. And we'll soon have instrumentation for fast MCP cloud through Logfire. In fact, you can do it today. I could show that as well. But in this case, we have an MCP client and an MCP server, and the MCP server is responsible for generating an image as SVG and returning it, and then the client saves it. And so if I go and run that example, and it's called PAI, I'm in the wrong directory. I run the client. The client will obviously run the server, connect to the server, and ask it to do some stuff. And I'll come back here, clear my query, and come back here to this ongoing span here, and you'll see it running. And what's powerful here is we start from within the client. You'll see MCP client. Then we make calls to the MCP server, because if we have the MCP server instrumented, we have this distributed tracing. It all just works, even though they're a separate process. They could be running on completely separate machines. Then we run a tool, image generate. So the client says, I want to call image generate. The server then gets that call to image generate. In this particular slightly mind-boggling example, the tool uses MCP sampling, which is a very confusingly named bit of MCP, where you can proxy LLM requests through the client. So we get back to the client, the server eventually generates the response, and then we return that. And so obviously you can look at the top level LLM, Pydantic AI agent run, or we can look at the kind of, there's another Pydantic AI agent inside the server. Does that sort of make sense? I mean, we're doing some relatively complex things here where we're switching back and forth between the client and server, but while this is complicated, it's a heck of a lot less complicated than trying to work out what's going on without something like Logfire to show you the distributed tracing.
Yeah, there's a really good question in the chat. And I think, could you talk a little bit more about distributed tracing in general? Because I think that's exactly the kind of thing that Logfire kind of, where it makes something that's really, really difficult and complicated and actually makes it manageable.
Yeah, absolutely. So distributed tracing, I'm not going to claim that we invented it. It's part of OpenTelemetry, but we just make it super easy to get set up. So you'll see that and in fact, distributed tracing for MCP is not a standard yet. We do it the same way that Microsoft do it for their SDK. But basically, we inject information about the current active trace and span into the request to the other service. So in this case, it's over MCP, but it could be over standard HTTP or any other mechanism to propagate that context. And then both the client and the server send through their traces. And then Logfire UI is responsible for basically assembling them into the trace that you see here. So you can kind of seamlessly see data switching back and forth between the two. Does that sort of answer your question?
I think so. Lou, please feel free to unmute or say if you have more questions.
I have another that might be interesting to see. So look at this service. You'll say this is a service. You can see it at where is it? Demo.logfire.dev. Is that where it runs? No, that's the wrong service. I've forgotten where it's actually hosted. I haven't used this for a bit, but the idea of this is that we're playing Connect 4 against either two AIs against each other or human against an AI. And so in this case, we're actually running a very simple Minimax model in TypeScript as a separate service. And you can see we have the full request going in as basically the AI makes a move and then the other AI makes another move. But yeah, you can see we go from the Connect 4 service into this C4 AI service. In this case, we switch both machine and language. So this is Python outgoing HTTP request in this case, and then this is the incoming HTTP request. This is the JavaScript instrumentation of the Minimax model, but you get this like immediate seamless view of the distributed trace going across the different services, and we can have more than two services and it will all just work. Make sense?
Yeah, it's very cool. I'm definitely going to experiment more with Logfire MCP. I don't know, Samuel, so I don't want to keep you here all day, but if you have a few minutes and you want to show us the new stuff you're developing for evals, I'm very curious.
Yeah, of course. I've remembered where it is. Logfire.run is here, so you can go and play the Connect 4 game here. And in fact, this invitation might have expired, but I can generate an invitation. So if anyone would like to join Logfire and look at these traces for this project, if I generate a new invitation, and I put that into the chat. If you have a Logfire account, or if you sign up for one, you can follow this invitation to go and both view these traces and what's going on here. And you can see stuff like database queries because it's general observability, or more complex printing, or the AI cases. And you can go and actually play Connect 4 and against any of these models. But it turns out that LLMs are terrible at playing Connect 4, and this local Minimax model is by far the best model for playing the game. So I won't subject you to a big example, but you get the idea. yeah, let me quickly show you the evals use case. So I'm not going to run through the full background on this, but this was an example we actually built for, I'm on the wrong project. That's why. This was an example we built for medical companies. In this particular case, we're running, we have an agent for, let me share my screen and see if I can find that code for you. Please excuse me 1 minute. So the idea of this code is that we have, we're doing pre-auth for an MRI scan. So the idea is that, like, when you go to hospital in the US, you have to, the hospital has to ask your insurer whether or not you're insured to get the MRI scan. And so we can use an agent to go and effectively evaluate whether or not your case is suitable to have an MRI scan. I won't mention anything to do with the morals of how the American healthcare service works. This is just the example I happened to have earlier. But the point is, we have a bunch of examples from prod, effectively, or equivalent, of actual MRI scan, actual requests. And then we want to go and eval running that agent against those real life inputs, against the golden data sets, to see how they behave, how well they behave. And so have a number of different examples here, but where we run different models. And sorry, let me, you would see the different experiments in that view. And then this is the view to basically see how the two different runs compare. One is using, it doesn't show it here, and we're just working to improve this now, but these should show that one is using, I think, 4.0 and one is using GPT-5. And you will see how the different assertions pass and fail, and when they fail, like why they fail. We have stuff like, let me turn on diff, and then you would see the diffs in stuff like the duration, but also diffs in the different scores that you got whilst running your evals, as well as obviously the kind of deep dive into the particular inputs that you got and then the outputs in each case and how they related to, so this is the expected output and then this is the actual output of the different models. And how they performed. And obviously, the powerful thing here is that because this is all just stored as OTel data, as tracing data, we can go and look at a particular case where it ran with this particular model, and we can see exactly what happened within this particular case and the actual traces within it, and and we go right down to the particular LLM call that contributed to this particular case. Does that make some sense, Eleanor? I can show a bit more. This is in beta now. We take it out from behind a feature flag yesterday, so it's still nascent, but I think it's going to be super powerful.
And this looks great. And yeah, like all the Pydantic stuff, it doesn't hide the complexity. It just makes it manageable. What's the status with it? Is it something we can use, or are you still kind of developing it?
No, you can use it now. I think if you sign up for an account, it's not behind a feature flag. It'll just be there with the beta label. I think our documentation is in Pydantic AI. And if you follow through this documentation, basically if I look at the actual code for sending it, if this is where we're running the evals, ultimately we're using Pydantic evals. We set up our data set. In this case, we add an evaluator and we just run evaluate with a max concurrency and a name for the case. And that's all we need to send that. Obviously, we have, we've configured Logfire here, instrumented Pydantic AI, and that's enough to then get that data in Logfire and visible.
All right, that's great. So last chance if anyone has any questions or anything. Oh,
I'll just mention quickly. I should have said this example here I'm showing is not open source. I think we need urgently a better example of evals that's perhaps a bit less politically charged than US insurance, that you can go and demo. So we will have that up soon. If you follow us on Twitter, we'll say something once we have that up. But I mean, in theory, the documentation is all there. Obviously, a nice complete example would be useful. Yeah, I'll stop sharing there.
So thank you. This was Brilliant. Really love the tour. I really have now the urge to go and hook up Logfire MCP to my agents and see how I can get this workflow to work. And also very curious about the evals.
Yeah.
And if
Just
everyone,
I saw there was a question. Sorry, I saw there was a question on how evals are defined. We have
Oh,
a bunch
yeah.
of pre-evals that will do common cases like LLM as a judge and is instance and things like that. But in this particular case, fundamentally, it's a data class that inherits from the evaluator and like returns ultimately in this case a set of different scores. Or so this is obviously a Boolean. Decision is correct. Match similarity, either assertions or scores, which become scores on the evaluator, on the evaluation. Does that make sense? I didn't see who asked the question. Louvre, yeah,
Yes.
great. And although this code isn't open source, I do believe that our docs for evals are pretty comprehensive on there. So here's an example of building an evaluator, and there are more complex cases or examples in the docs here. So LLM as a judge, for example. Sorry, Eleanor, I interrupted you.
No, just I was confused. Right? I thought you were saying, no, I can't show you the code because we don't have an open source example, but I think that was already a really good glimpse of how to write these evaluators.
Yeah, no, that particular code isn't open source. I'm happy to walk through it here, but we will have soon a full example up.
Cool. All right. So if nothing else, thank you so much, Samuel. This was really, really cool. And everyone, yeah, give Logfire a try. It's quite surprising. It's a bit hard to get just how easy it is to use without actually using it. So just and you have quite a generous kind of free tier, right, for people to experiment with.
Yeah, we do. We have you get 10 million spans a month free. I think we also gave some free credit. Is that right?
Yes.
But even without that, honestly, the 10 million free spans a month is enough for, particularly in the AI context. You can do an awful lot of stuff on the free tier. Wonderful. Thank you very much.
All right. Thank you. Thanks, everyone. Bye.
Thanks a lot. Bye bye.